Hello and welcome class. So in today class I am going to teach you about the application of ultrasound. In last class we learned about what is ultrasound or ultrasonic sound. Any sound which has frequency greater than 20,000 hertz comes in the category of ultrasound. Ultrasound. So now we are going to learn about what are the application of ultrasound. Application of ultrasound. Ultrasound are high frequency wave. They are high frequency wave. Their frequencies are greater than 20,000 hertz. Ultrasound are able to travel along a well-defined path even in the presence of obstacle. Because ultrasound wave has high frequency, it means it has high energy. So it is able to travel very long distance even if it has obstacles in its path. Ultrasound are used extensively in the industries and for medical purposes. So ultrasound have a huge range of variety and usage in industries and in medical purposes, and we are going to learn about that. Ultrasound are generally used to clean part located in hard to hard reaches places. Okay, ultrasound used for cleaning and used to clean those parts which are hard to reach. For example, any spiral tube. If we have any spiral tube, something like this, a tube, so it is very hard to clean by hand. So we will use ultrasound frequency to clean such things. Okay, spiral tubes, odd shaped parts, electronic component, those are not washable with water and hands. Okay, those are used. So ultrasound is used to clean this type of substances. Object to be cleaned are placed in a clean solution. In a container, we placed a cleaning solution and put that part in it, and then from this solution we sent ultrasonic or ultrasounds, and this from this ultrasound wave inside wave is generated which used to clean the part of the object. Object to be cleaned are placed in a cleaning solution and ultrasound wave are sent into the solution. Due to high frequency, the particles of dust, grease, oil, dirt get detached and drop out. Hence, the object does get truly clean. So this is first application of ultrasound. It is used in a cleaning purpose, and how we use it as a cleaning purpose. We put the object which we want to clean in a cleaning solution, and inside this solution we pass ultrasound frequencies. Okay, so all the dust particle which is present on the surface of the object get detached due to ultrasound wave, and that object get clean thoroughly. Now next application of ultrasound is ultrasound can be used to detect cracks and flaws in a metal block. In construction of big structure like building, bridges, machine, and also scientific equipment, if we want to detect any crack or metal flaws which are not visible from the naked eye, we can use ultrasound for it. How we can use ultrasound for detecting cracks? Okay, you can see it from this example. Suppose this is our metal block and it has a crack here. Okay, so what we will do, we will place this metal block in a container, and in the container we will pass ultrasound wave and put detectors on another side of the container. Okay. If there is no defect, the ultrasound wave will pass throughly, but if there is any defect or flaw, the ultrasound wave will be unable to pass and detector will not detect any wave. And if the detector is not detecting any wave, it means there is a defect or flaw. The crack or holes inside the metal block, which are invisible from outside, reduce the strength of a structure. Imagine you want to build a building. If your metal blocks have any defect, then it will decrease or reduce the strength of the structure, and we want no defect. So, to detect the defects, we will use ultrasound. Ultrasonic waves or ultrasound are allowed to pass through metal block, and detector are used to detect the transmitted wave. If there is even a small defect, the ultrasound get reflected back, indicate the presence of flaw or defect, as I showed you in this figure. If detector is not detecting any wave, it means there is a flaw in the metal block, and we will not use that metal block for the construction. Okay. So the structure of the building will not get compromised. So that is the second application of the ultrasound can used to detect defects in the metal block. First use was cleaning purpose. Now another use of the ultrasound is ordinary sound of longer wavelength cannot be used for such purpose. It will bend around the corner of the defecting location and enter the detector. If we do not use ultrasound waves, we are using other wave to detect these flaws. If we do not use ultrasound, if we are using different waves, then what will happen? That different wave will get deflected in different direction, and those can detect by the detector, which is not useful for us. So for this purpose, we can only use ultrasound wave because it has high frequency. Ultrasonic waves are made to reflect from various parts of the heart and from the image of the heart. Okay, and this technique is called echocardiography. So this was the application of ultrasound for detecting flaws. Now, another application is ultrasonic waves are made to reflect from the various part of our heart and form the image of the heart. And this technique is known as echocardiography, used by the used in the medical purposes. Ultrasound scan is an instrument which used ultrasonic wave for getting image of internal organ of human body. Okay, and that image of internal organ of the human body can be used by the doctor to about uh, check the health of the patient. A doctor may image the patient organs such as liver, gallbladder, uterus, kidney, etc. It helps the doctor to detect abnormalities such as stone in the gallbladder, kidney, tumor in the different organs. Okay, so ultrasound is also used in medical purposes. Like we have learned about echocardiography, where doctor used to take the image of our heart by using ultrasound. Ultrasound scanner is an instrument which used ultrasonic wave to get image of different organ of our human body. A doctor can take the image of patient organ like liver, gallbladder, uterus, kidney, etc. to detect the stones in these organs. Clear, class? In this technique, the ultrasonic wave travel through the tissue of the body and get reflected from different region where there is a change of the tissue density. Okay, if this is our tissue, okay, tissue, and here is the abnormality. This is the abnormality. So what will happen? We will pass ultrasound wave. Most of the ultrasound wave will pass through easily because there is not a defect. But where is the defect? The ultrasound will reflect back and we will take the image of this reflected ray and can see the defect inside our body. These waves are then converted into electrical signal that are used to generate images of the organ, and these waves are converted into electrical signal, and that's how a image is generated of our organ. Is it clear, class? So it is the third application of ultrasound, helps to detect the internal abnormality of our body. These images are then displayed on a monitor or printer on a film. This technique is called ultrasonography. Okay, this technique is called ultrasonography. Ultrasonography is also used for examination of fetus during pregnancy and to detect congenital defect and grow abnormality. Ultrasonography are generally used to examine the fetus during the pregnancy, that fetus is in correct state or not. Okay, and also used to detect different type of defects and abnormalities inside the body. Ultrasound may be employed to break small stones formed in the kidney. Okay, through ultrasound, we can also break the small stones which are formed in the kidney into fine grains, and this grains is later on flushed out with urine. So, ultrasonography is another application, and usage of ultrasound to break stone is also the one of the application of ultrasound. Now, what you have learned from this chapter is completed. Now, we will take a quick summary of this chapter. Okay, and what is the summary of this chapter? How sound is produces. First of all, what is sound? Sound is a form of energy which enable us to hearing or give the sensation of hearing to our ear, and sound is produced due to vibration of different object. When different object vibrate, it force its adjacent object to vibrate, and that's how sound travel. Sound is a longitudinal wave. In class, I have explained you that there are two type of wave. One is longitudinal and other one is transverse. Sound is a longitudinal wave because the disturbance and the propagation of sound is in same direction. Sound travel as successive compression and rarefaction in the medium. How sound travel? There is a series of compression and rarefaction region in the medium, and through this compression and rarefaction region, the sound propagates. And sound require medium to travel. In sound propagation, it is the energy of sound that travel and not particle of the medium. When sound propagate, particle does not travel, only the vibration travel, or in other sense, energy travels, but particle does not travel. The change in density from one maximum value to minimum value and again to the maximum value make one complete oscillation. We have studied the distance versus density graph of sound wave. Distance versus density curve, and we have seen the curved like this. Okay. So when a sound wave from 0 to reach maximum, then reach minimum and again become 0, this part only is called what it is called? It is called one oscillation. One oscillation. Okay. The distance between two consecutive compression or two consecutive crust or two consecutive rarefaction or two consecutive trough is called wavelength. The distance between two consecutive crust or trough is called wavelength. Lambda is the symbol of wavelength and its SI unit is in meter. The time taken by the wave for one complete oscillation of the density or pressure of the medium is called time period. This is one definition of time period. Another definition is how much time two successive crust or trough take to pass from one place. Okay. Or time taken by the wave to complete one oscillation is known as time period. Okay. The number of complete oscillation per unit time is known as frequency, and there is a relationship between frequency and time period is that frequency is inversely proportional to time period. Now next formula, if speed is v, frequency is nu, this is the symbol of frequency nu, and wavelength is lambda, then the speed of sound can be related as v equal to lambda nu, or velocity is equals to um, speed is equals to wavelength times frequency. This is the formula for speed of sound, and frequency nu is reciprocal of time period. There is difference between time taken by the wave and time period. Time period is how much time a wave take to complete one oscillation. Clear, class? The speed of sound depend primarily on the nature and temperature of transmitted medium. Speed of sound depends on two things. Okay. One is medium and another is temperature. We know that speed of sound in solid is greater than speed of sound in liquid, and speed of sound in liquid is greater than the speed of sound in gas. And why it is so? Because the particles in solid are closely bound in comparison to gas and liquid, and how close the particle is, that much fast the vibration will travel from one particle to another. So speed of sound depends on medium. It also depends on temperature. If we increase the temperature, then the air molecule will vibrate more fastly and sound is made from vibration. So if we sound got anything which has already vibration, so vibration can get transmitted easily from one particle to another. So as the temperature increases, the speed of sound increases. Clear, class? So speed in solid is greater than speed in liquid is greater than speed in gas, and sound does not propagate in vacuum because vacuum has no molecules, no particle. And what about temperature? As temperature increases, speed of sound increases. Clear, class? Okay. Now next point is sound also follow the same law of reflection as light does. And what are the laws of reflection? There are two laws of reflection. Number one is incident ray, normal ray, and reflected ray lies on the same plane. And law number two is angle of incidence is equal to angle of reflection. So sound follow the laws of reflections. Clear, class? For hearing a distinct sound, time interval between the original sound and reflected sound, one must be at least 0.1 second. In order to hear echo, okay, in order to hear echo, the time interval between transmitted sound wave and reflected sound wave should be at least 0.1 second. Otherwise, you will not be able to hear the echo. Okay. The persistence of sound in an auditorium is result of repeated reflection of sound and is called reverberation. The persistent sound in an auditorium, whenever you go in big auditorium, you hear some repeating sound. Okay, it is the result of repeated reflection of sound wave, and this phenomenon is known as reverberation. Sound properties such as pitch, loudness, and quality determine the corresponding wave property. So, sound has some property. First of all, pitch. Pitch is the consequences of frequency. Higher the frequency, higher will be the pitch. Loudness is from amplitude. Higher the amplitude, more louder will be the sound. And third factor, quality. Quality of sound help us to distinguish between two different sound if both got same pitch and same loudness. Okay. So pitch, loudness, and quality determine that sound has wave property. Okay, sound is the wave because it got frequency, it got amplitude, and how much energy we will give can increase the amplitude, and how fast the source is moving gives the frequency. So it corresponds to the wave property of sound. Sound is consist of wave. Loudness is physiological response to the ear to the intensity of sound. Loudness and intensity are two different things. Loudness depends on energy. Loudness directly proportional to energy, and intensity is equal to energy per unit area into time. So our brain interpreted loudness and intensity by same thing, but they are not actually same thing. They are different thing. Loudness is a psychological response to the ear to the intensity of sound. If sound has higher intensity, our brain will interpret that it has high loudness, and our ear will respond to it. The amount of sound energy passing each second through a unit area is called intensity of sound. The amount of sound energy passing each second, okay, this is the formula of intensity, energy divided by area into time. The audible range of hearing of average human being is, you have to memorize this quantity, 20 hertz to 20,000 hertz. These are the audible range of human ear. Okay, 20 hertz to 20,000 hertz. Any frequency less than 20 hertz will called as infrasonic, and frequency higher than 20,000 hertz called as ultrasonic wave. Ultrasonic wave or ultrasound has many medical and industrial applications. Okay. And from this topic, our chapter sound is being completed. Okay. In sound chapter, we have learned what is sound, how it produce, how it propagate. And then we have learned about the characteristics of sound. Then we learned about some new term that what is amplitude, loudness, pitch, note, tone, and then we learned about echo, reverberation, laws of reflection. After that, we learned about the application of sound, hearing range, hearing aid, infrasonic, ultrasonic, and how ultrasound is used in different areas. From this topic, our chapter sound is being completed. Thank you so much for being with us. In next class, we will practice the questions which are present in the NCERT exercise of chapter sound. Thank you so much.